Hi, my name's Peter Frank and I'm the CEO of Product Innovation Limited. My company has recently developed a novel, unique liquid level sensor that works on an optical principle. It's been used so far in the refrigeration industry, where it's used to measure liquid refrigerant, and the largest supermarket chain in the country has these installed in their refrigeration systems. Here's the product itself, and you can see that there's a range of black dots at the top and white dots at the bottom. The white dots are infrared LEDs. The black dots are photosensors. And what happens is the electronics scans down in pairs, looking for the reflections, which I'll describe in a minute, until the first point where it detects liquid level. So let's go back to the main screen and I'll explain a bit more about how it works. Here you can see on the left a section where there's an LED shining its light, and it comes up to the surface of the rod, gets reflected across and comes back down to the photosensor. The photosensor gets a signal which it senses. But when the same thing happens under liquid, the LED shines its light, but it doesn't reflect. The light gets dispersed in the liquid, and consequently the photosensor sees nothing. So what we're seeing in the electronics is the first point at which there is no return signal, and that indicates the liquid level. This is particularly useful in many industries where there might be a need for no moving parts and solid state, where there might be high pressure with the liquids, or there might be an aggressive liquid like an acid that's difficult to measure otherwise. What the electronics sees as it scans down all of these pairs of sensors is a series of reflections. Here, all these peaks indicate one pair of sensors, each one showing a good reflection. That means that there's no liquid present. But if I put the rod in the liquid partially, you can see now all those first peaks have disappeared. And this is the first peak, and that's now showing, and that shows the liquid level. We show that to the outside world with a voltage. The voltage is a 0 to 5 volt output, and other voltages are available, including other outputs, I beg your pardon, are available, including digital. But the customer on this occasion wanted this 0 to 5 volts. Here you can see when there's no liquid, the red line indicates a low voltage, showing that there's no liquid. Go back to where the probe is partially immersed, and you can see that red line has moved up significantly, showing that the voltage output, it corresponds to the actual liquid level. I'm now going to demonstrate this live using this pot of water here and an active probe and the oscilloscope that I've got set up to measure the real live signal. Let me put that down and switch to the oscilloscope. There it is, the same picture as before, but this one is actually live, and you can see here all the peaks that we had before. But as I put the rod in the water, those peaks slowly disappear until the rod is fully down in as far as it'll go in the liquid. Take it out again, and here come the peaks again. So you can see that you get an instant response to the liquid level, no moving parts, nothing to go wrong. Well, I hope you found that explanation and demonstration interesting. We'd love to hear from you. If you have any applications or questions, please feel free to contact us at www.productinnovation.com, or you can email us at optical@productinnovation.com. Thanks.